this session, let's see how to accelerate your Databricks projects with access to semantically rich SAP data using SAP Datasphere. Hi, I'm Sangeetha Krishnamoorthy, a Senior Solutions Architect with the Platform Adoption and Advisory team with SAP, and I work on reference architecture for hyperscalers.
And my name is Chi Su. I'm a Senior Solution Architect with Databricks, leading customer engagements globally for our SAP Specialist team.
SAP Datasphere is the foundation for Business Data Fabric architecture. So what is Business Data Fabric? It is the architecture of interwoven technologies that enable seamless and scalable access to business data without duplication. Now, why is this important? In the past, organizations used to consolidate data into data warehouse, and the cycle of extracting data, losing the data context, and then rebuilding the lost context and semantics took up countless resources and weeks or months to complete. Businesses have learned that they need quicker access to data so they can react faster to economic signals and changes in the market. This is where Datasphere can help. SAP Datasphere provides governed and seamless access to critical business data with the business semantics and the context intact for your AI and data projects. Running on SAP Business Technology Platform, SAP Datasphere enables powerful open data ecosystem and provides an unification experience with self-service access to your distributed data and with centralized data governance layer, data cataloging, and semantic modeling capabilities.
The Datasphere platform is complemented by the Databricks Lakehouse. Databricks pioneered the Lakehouse market segment, combining the best of data lake and data warehouse, providing cloud-native scalability and elasticity, offering data management for structured, unstructured, and semi-structured data, and providing a platform for data engineering, streaming, data warehousing, and data science workloads, including machine learning, AI, and generative AI. As we mentioned, the Datasphere and Databricks Lakehouse platform are highly complementary. Together, they provide the unified mission-critical SAP, non-SAP, and unstructured data, and offering capabilities for end-to-end data, analytics, and AI to help enterprise customers generate valuable insight. Sangeetha and I will be covering the currently available bidirectional data integration. I will start with the Databricks federation to Datasphere. So this is available today through Databricks notebooks via the support of the FedML Databricks Python library that is open sourced by SAP. So this allows Databricks notebooks to integrate by querying the OpenSQL schema of Datasphere to access SAP application data that's available in Datasphere with context. And we will show a demo of that in a minute. So this is available in the notebooks today, and the same capability will be available in Databricks SQL via Lakehouse Federation in the near future. For data engineers and data scientists who are working in a Databricks notebook, this allows them to unify and harmonize SAP as well as non-SAP data, SAP data from Datasphere and non-SAP data already resident in the Lakehouse. There are a lot of different use cases of blending SAP and non-SAP data that this enables. For example, in asset-intensive industries, customer may need asset master data or bill of material data. They may need from the SAP Enterprise Asset Management or plant maintenance modules, the work orders. And in the Lakehouse, they probably already have IoT kind of sensor data. They might have external third-party data like weather and so on. So all of these valuable data sources, structured and unstructured and semi-structured, need to be blended together and with data science applied to build and train and deploy models for application use cases such as predictive maintenance. And with the insights that are generated, we may also want to write them back to Datasphere for additional reporting and other purposes. So the possibilities are endless all the way to the current trends in generative AI and large language models to train on SAP application data to make inferences. And so now we will show a quick demo of this functionality. Let's take a look at how Databricks notebooks can federate to Datasphere and be able to access in real time SAP application data that are available there. So to start, we'll go to the Datasphere side where SAP colleagues have kindly provided me access to a Datasphere tenant. So here we're going to be we're looking for our objects related to the sales document. So let's open this up here. And we can see that it is an object that is from a source S4 system, and it is a CDS view. Right? And this could be replicated as well as virtualized. Let's go look at a view that I've already built on top of that. And that is this object here. We'll see that it is a simple projection view. So we'll take a quick look at the columns. See that the sales document, the item object is a very wide object. So there are many columns out of the CDS view. What we see here in the projected output, it is a pretty narrow set only of 6 attributes: sales organization, document, materials, and so on. And we also see that because of this CDS view, so we're getting access to the business name rather than the technical names. So before we jump over to the Databricks Notebook, one more thing that we need in order to make the connection from Databricks Notebook to Datasphere via FedML is that we need the access information, credentials, and so on. So for that, we go to Spaces Management in the Database Access section. And if we don't already have a OpenSQL Schema database user, we do need to create one. And then we can look at the information here and copy down the all this connection information and the credentials information. So let's switch gears to Databricks Notebook. The first thing we do is we need to install the FedML Databricks library, which is a Python library that SAP has open sourced. And then we need to provide the connectivity information we just saw that came from the database access section of Spaces Management in Datasphere. This gives us access to the OpenSQL schema under the Datasphere tenant. And we put this into a JSON configuration object. And then we import the database connection object of the FedML library. And we'll initialize the connection. With that, we have a connection object, and there's a help method to show us all of the available methods in this class. We can go get the schema, all the views that are within a particular schema, and we can also issue a SQL query. So this is the execute query PySpark method, which returns a Spark data frame that is distributed on the Spark cluster that I'm using. So we can just do a select star from the view 1 object that we were just looking at. That is the 6 columns and limit 100. So we can see here the columns and the values that we're getting. And then next we can actually push down a analytical query to the Datasphere tenant, right? But here we're performing an aggregation, looking at the total sales by sales organization, right? And so we see that there are 33 different sales organizations and their corresponding sales. There are a lot of other use cases, and also we noticed that we are seeing the business names that are passed through rather than the technical names of objects, just because we're integrating with the CDS views through Datasphere. Now, there are a lot of possibilities for us to retrieve data as well as do analytics against Datasphere. More interesting use cases, including that we can bring the high-value SAP Enterprise application data over, such as sales in this example, and build advanced analytics. For example, building a sales forecast using open source algorithms such as RIMA or Profit, and we can do that at scale for each sales org or for each material group and so on. We can also unify the SAP data, in this case sales data, with non-SAP data. For example, enriching the forecast by incorporating macroeconomic data, weather data, so on. And then for CPG customers, right, you might want to mash up the sales data with third-party POS data to understand correlations between the sales versus the retail sales. And then on all of these cases, we might want to write back, for example, the forecast we were talking about back to Datasphere as well, to share that data-driven insight with the Datasphere users and also with SAC. And just the last plug is that our team is working with Sangeetha and the Datasphere team to build out more end-to-end demos.
With the second reference architecture pattern, data from Databricks Lakehouse, such as the external signals, can be harmonized with the critical business data in SAP Datasphere. in real time without copying or duplicating data. This is a real-time data federation. Generic DBC connector helps connect to the Databricks Lakehouse and remotely access and blend all the data in SAP Datasphere analytical models. The queries are directly federated into the Databricks compute clusters. The blended data can be used for advanced 360-degree analysis or planning use cases in the SAP Analytics dashboard. We'll now see a demo of this pattern. Let's see how harmonization of SAP business data and Databricks Lakehouse data using SAP Datasphere helps a logistics command center at a company. Trucks which carry frozen food products from shipment center to the retail stores have IoT devices embedded in them. These devices track the truck location, the freezer temperature, the number of times the doors were opened and closed, etc. The data streaming in from these IoT devices are stored in Databricks Lakehouse. This data is unified with the shipment data from the SAP business systems, such as the destination, the customer information, the products in the truck, the route, the ETA, etc. Data thus harmonized via the Datasphere models are visualized in this Analytics Cloud dashboard and provides end-to-end visibility in real time to the logistics manager, who can now act when a shipment needs attention, and he can act in real time. For example, when a truck freezer temperature goes above a safe limit. So let's filter down on a particular location ID, 2141. And now the query is federated directly at Databricks and it's filtered. And we know that this truck needs attention. Now let's navigate into the Databricks compute cluster and look at the SQLs that got executed. And you can see that the latest query that we ran is actually here locked in the Databricks cluster. And if he wants to filter down on a particular shipment ID to see what's happening and drill down into the details, he can click on it and then navigate into the route details, which is actually coming in real time. And he can now see that the route is actually originating from the Georgia and ending in South Lawndale in Chicago. And you can see the truck is almost 3/4 away. And now he can take an informed decision based on the current situation. We can now see how SAP Datasphere can be used to federate the queries live into the Databricks Lakehouse and be used to create visualizations in real time that will help a logistics manager to have end-to-end visibility. You can now see how Datasphere can be connected to the Databricks. This is very easy and intuitive interface. This interface lets you enter the JDBC connection details from the Databricks cluster and the username and password along with the data provisioning agent information. The username and password are nothing but the user tokens from the Databricks workspace. This solution diagram depicts the integration patterns between SAP Datasphere and Databricks Lakehouse. So for the first architecture pattern that she mentioned, we use a FedML Python library that is freely available to be installed by data scientists in the Databricks notebook. And that helps connect to the SAP Datasphere and then federate the data live for the data scientists to do advanced analytics and machine learning in the Databricks notebook. And this also enables them to write back the predicted results into the Datasphere and the modeled unified models in the Datasphere that can include the SAP data and the predicted results can be used for upstream reporting and other use cases. And for the second architecture pattern, we use the generic JDBC connector and connect the SAP Datasphere with the Databricks Lakehouse. And we use data provisioning agent that can federate the queries live into the Databricks for analysis in the SAP Datasphere and trickled up to the SAP Analytics Cloud. Thank you for attending the session. I hope this was useful to you. And if you have any more questions, feel free to reach out to us anytime. And I hope you enjoy the other sessions of the TechEd. Thank you.
Thank you.